f cos of 2 lambda t. We don't have x here, we're gonna keep it the way it is. H of sine 2 lambda t, and then we equate it to what? To 0. Why? Because our condition says is equals to 0. But then if you look at this function will also never be equals to 0. This function here will never also be equals to 0. So we're going to have sine of pi lambda, which is equals to sine of n pi. Ne? We're equating it to 0. It's sine of lambda. It's actually sine of pi lambda is equals to 0. But we know that from Fourier, we have sine of n pi, which is equals to 0. That's why equating this, because they're both equals to 0. Therefore, if you are having sine and sine, you can literally just equate the argument. So we're going to have pi lambda is equals to n pi. If we divide both sides by pi, we're going to have lambda, which is equals to what? Lambda, which is equals to n. So we're going to substitute the value of n where? Into this equation. Wherever we see lambda, we're going to put n. So we'll end up with a new equation. We're going to end up with u of xt, which is equals to what? Sine of nx into what? f cos of 2 n t, yes, plus h sine of 2 n t. Okay, cool. So now we have our third condition which we need to substitute, which is u of x0 is equals to 0. Let's substitute our third equation, third condition. U of x0 is equals to 0. It means when we see time, you're gonna put 0. So you're gonna have u of x0 is equals to what? Sine of nx into f cos of 2n into 0 plus h sine of 2n into 0. Already we know that the sine of 0 is going to be out, and then the cos of 0 is going to be 1. So we're going to end up with u of x0, which is equals to f sine of nx, which is equals to what? Is equals to 0. But the function of sine can never be equals to 0. The function of sine can never be equals to 0. This implies that f is going to be equals to what? F is going to be equals to 0. Why? Because if you multiply the function of sine with 0, you're going to get 0. It means the left hand side will be equals to the right hand side. Since now we have the value of f, we have to substitute it where? Back here. If we substitute f to be 0 here, it means that this whole guy is going to die. So we'll be left with the function u of xt, which is equals to what? This guy is dead. It means h sine of 2nt is sine x nx sine nx multiplied by what? H sine of 2nt. Okay, cool. We are here. And then let's move to the last condition. The last condition, it says what? It says ut into x of 0. We have the last condition, which says ut into x of 0 is equals to what? Sine x. This is the last condition. But you need to be careful now. If you look at the other conditions, you were just given or u of x0, it means they were just varying x and time. But if you look at this one, it's having u of t. What is this t? What does this t mean here? This small t here. It means you have to take the derivative of this function here, and then you substitute t with what? With 0. So ut of xt is going to be equals to what? Please forgive my pen. My pen is dead. When I have sine of nx, and then if you take the derivative of this, you're going to end up with 2n h, and then cos of 2nt, and then you're going to equate it to what? You're going to equate it to sine x, ne? You're going to equate it to sine x. Okay, cool. Now we are here. How do we solve this? How are we going to solve this? Let's see. We have sine of nx, 2nh cos of 2nt. So we need to substitute our condition here, which is u of x0. Oh no, I made a mistake here. We were just differentiating. We were just differentiating u of t. We're differentiating. After differentiating, that's when we're gonna substitute this condition. So we first differentiated this function because the condition says we must have u of t, I mean. And then after now, we're going to substitute the conditions. So we have u of t, which is equals to sine nx 2nh cos of 2nt. And then now we need to substitute the value of t with 0. We see t, we're going to put 0. So we're going to end up with what? We're going to end up with sine of nx 2nh, the cos of 2n multiplied by 0 is going to be equals to what? To sine x. So now we know that this guy is going to be 1. So we'll be left with sine of nx 2nh multiplied by sine of nx is equals to sine of x. So for you to equate the right hand side and the left hand side, the argument, it must be the same. It means for this argument here and this argument, it must be the same. How can you make the left hand side to be and the right hand side to be the same? It means for n must equal to what? N must equal to 1, so that you can be able to take the coefficient of 2nh and then equate it to 1. So we said n is 1, so we're going to have 2 into 1, h is equals to 1. This implies that h is equals to what? 1 over 2. If h is equals to 1 over 2, and then we can write our function as u of x. U of x, we have h here. U of x as sine of x sine of x, let me see, sine of x, we put 1 here. Okay, let's try this again. We have h, which is equals to 1 over 2. So if we substitute the value of h into the original equation here, we're going to have u of xt, which is equals to sine of nx. Our n is 1, so it's going to be x, and then times h. Our h is 1 over 2. And then sine of 2 is there, and then n is 1, so we're going to have 2t. So our function is u of xt, which is equals to sine x is 1 over 2 sine of 2t times sine of x. So this is the final answer for the wave equation. Let me just quickly go through recap with you. Let's start from the beginning. Okay, we have our function. This is solve the following wave equation. I have said c is equals to 2. Why? Because c squared is equals to 4. If we take the square root, we're going to have c is equals to 2. Wait, the first two are our boundary condition. The second two are our IVP. So we're going to substitute the value of the first condition, the second, third, and the fourth until we get to the answer. So this is the equation which is governing the wave equation. So c, it was 2. So we're going to substitute 2 here. And then after, you're going to end up with this equation. And then after that, you're going to substitute the first condition. Where you see x, you're going to put 0. And then if you solve that, you're going to end up with a, which is equals to 0. Why a is equals to 0? Because this function inside can never be equal to 0. So we let a to be equal to 0, because if you multiply a by everything, it's going to give us 0. And then we substitute the second condition. We do the same thing. And then the third condition. And then the fourth condition, it had ut. It means we had to derive it first. So we must first take the derivative, and then after taking the derivative, and then we we solve. We substitute the secondary, the fourth conditions, and then we solve. And then u of xt is equals to 1 over 2 sine of 2t sine of x. So this is how we solve. The other problems, they're gonna follow the same process. Just try them out. Please comment below and tell me what you think about this video, or you can direct me. You can comment below if you have any question. I will respond with a video. Sharp.